Welcome back everyone. In this episode we will see how to import the dataset that we said being a dataset of audio recordings of English numbers in order to start to tune our network on this specific dataset. This is not one of the most common dataset available in the Python libraries already, so we will need to clone the repositories from GitHub. And we can do this with git clone and selecting the link of the repository. If we now check within our directory, you see an audio MNIST directory appeared. Let me first of all remove the previous directories containing the VHDL code. If we look inside the audio MNIST directory, there is a data directory which is the one containing all the samples of these audio recordings. So Spiker Plus by default comes together with three datasets, as you can see in the paper: the MNIST, the audio MNIST, and the Spiking Heidelberg digits, or SHD. So for these datasets, it already contains default data loaders in order to simplify the import of the data. So from spikerplus.dataloaders we can import the specific data loader for the audio MNIST, which is audio MNIST data loader. And now you should be familiar on how to initialize the components of Spiker Plus and then to run the corresponding functionalities. So let's first of all instantiate the audio MNIST data loader, and we can specify the target directory in which the data will be stored. And in this case we will select audio MNIST/data, that is the directory that we saw contain all the data already. After instantiating the data loader, we can extract the train loader and test loader, calling dataloader.load. When loading the data, we need to specify the size of the batch that will be used along the code in order to train and test the model. And for this example we will use 64 samples for the batch size. Let's remove the creation and compilation and elaboration of the VHDL code, so for the moment we can test only the data loading functionalities. Now, in the tutorial number 1, we saw as Spiker Plus assigns default values to all those parameters that we don't select within the network. Now, since we are working with a specific set of data, let's pick a number of cycles and a number of inputs that corresponds to the input data shape. So we can access one element of the train loader using the next iter on the train loader, so to iterate over the first element of the train loader. And we will select shape 1, which contains the number of cycles. In particular, Spiker Plus expects to receive data that contains on the first dimension the batch size that we selected as 64, on the first dimension the number of time steps, so the number of cycles, and on the second dimension the number of inputs. So let me clarify this command with a comment to say that we are extracting the number of time steps from the input data, and then we can extract the number of inputs. As I said before, we can iterate over the first element of the train loader, and in this case we will select shape with dimension 2, so the second dimension of the shape that contains the input size. And now, since we extracted these dimensions from the input data, we can specify within the network description these two parameters. So instead of using the default, we will now specify the shape that we extracted. Okay, here I misprinted a dot instead of a column. Let's correct it. Running the script, you can see the new dimension assigned. In this case, the dimensions are are the same as in the previous case as the default, because the default is directly assigned with the audio emlist. But here you can, you will see whatever dimension you extracted from the input.